Greetings! Okay, we're going to take this word problem here, which is the beginning of a linear programming problem, and attempt to take this English and turn it into the Mathemagics. Okay, so that way we'll be able to approach the algebraic steps of the problem. So I'm going to go through and I'm going to underline the relevant information as we're performing or as we're reading. So it says, you need to buy filing cabinets for work. Cabinet X costs $10 per unit. It takes up 6 feet of floor space and it holds 8 cubic feet. Okay. On the other hand, we have this other kind of cabinet, and this other cabinet costs $20 per unit. It needs a little bit more floor space, needs about 8 square feet of floor space, and it holds a little bit more though, and it holds about 12 cubic feet. So along with this problem, we're also given some restrictions on our resources. So we only have a budget of $140. Our room only has a certain amount of space on the floor. It only has 72 square feet of space. And then altogether, we're trying to maximize the volume. Okay, so notice how I underlined everything in green and red and black to draw my attention to that there's 3 pieces of information going along with the cabinets, right? So one piece of information is we're trying to buy cabinets X and Y. We have some restrictions on the cost, and we have some restrictions on the floor space, and then we have this idea or this desire to kind of maximize the amount of volume. So first of all, let's define some variables in this problem. I will let X equal the number of cabinet X that we will buy, and we'll let Y equal the number of cabinet Y that we will buy. So that defines our variables so we can use them as we go further along in the problem. So first of all, let's set up a constraint based on the costs. So every unit of X that we purchase, every cabinet X costs $10, and every cabinet Y that we purchase costs $20. So if we add those together, that's going to be our total amount of cost, and according to the underlined green, we need to restrict this by 140 because our budget is only $140. Okay, next we have a restriction based on the amount of floor space. So every cabinet X takes up 6 square feet of floor space, and every cabinet Y takes up 8 square feet of floor space. Altogether, we know that the room only has 72 square feet of floor space, so that is also a restriction on our resources. Finally, oftentimes with linear programming problems, although not always, there's the trivial restrictions that we need X and Y to be larger than or equal to 0. In this context, it's because we will not be buying a negative number of cabinets. Okay, and then what are we trying to optimize in this problem? Well, we're trying to maximize volume. So I'm going to now set up a volume function. And the volume function, I know that the cabinet X holds 8 cubic feet. And I know that cabinet Y, each one of those holds 12 cubic feet. And so when I add those together, that's my optimization function because that's what I'm going to try to make as best as possible. I'm going to try to maximize my amount of volume. So that's in general how you can take a linear programming word problem and turn it into the algebra. And then we'll follow the last steps of the algebra in a future segment.